All right, here is your key to the Chapter 8 review. So first thing we're going to do is just expand using our composite properties. So this starts off as cosine x times cosine pi over 6 plus, you always have the opposite sign as that, sine x sine pi over 6 plus, now we're going to expand the sine one, sine x cosine pi over 3 minus cosine x sine pi over 3. So we go through and evaluate. So cosine of pi over 6 is square root of 3 over 2 plus sine x sine pi over 6 is 1/2. And then we have the plus sine x cosine of pi over 3 is 1/2 minus cosine x sine of pi over 3 is rad 3 over 2. So when you look across, you can see that this minus the first and last terms cancel, and then I have 1/2 sine plus 1/2 sine, which makes 1 full sine. And that is that. In the next one, because they're all sine, cosine, tan, cosecant, I'm just going to turn everything into sine over cosine, or sine and cosine. So then I have sine, I have cosine, and cosecant is 1 over sine squared. So let's see what cancels. So this will cancel with one of those. This will cancel with the other one. This will cancel with this, and they all basically cancel to 1. And you're done. All right, prove sine 90 minus theta equals cosine. So basically what we're going to do is just use our composite to expand this. So this is sine 90 cosine theta minus cosine 90 sine theta. And cosine of 90 is 0, sine of 90 is 1, so that leaves me with just 1 times cosine theta, which is cosine. Okay, in these last ones, it's really important that you draw the triangle in the given quadrant that they have here. So for triangle A, that is going to be in the second quadrant between 90 and 180. And this is the clues, so I know the opposite is 3, this is 5, this will be a -4. And to do the B triangle, it's in the third quadrant. And this is the clues, so this is a -8. That's 17, so the opposite will be a -15. Now that we have those, all you have to do is use your identity. So sine 2b is going to be 2 sine b cosine b. That's just the identity for sine 2 theta. And then we go to the triangle, which in this case will be the B triangle. And we fill in our ratios. So sine is going to be -15 over 17, and cosine is -8 over 17, and multiplying that all together is going to give me 240 over 289. Tangent 2b, we're first going to just write out the identity, is 2 tangent b over 1 minus tangent squared b. So we're using the same B triangle. So this becomes 2 times 15 over 8 will become positive. 1 minus 15 over 8 squared, which is 225 over 64. So we rewrite 1 as 64 over 64. this will cancel. So I have 15/4 times, I'm going to invert and multiply. So 64 comes up top. 64 minus 225 is a negative 161. So 4 goes into 64 16 times. And our final answer will be a negative 240 over 161. And the last one, cosine 2a. So you have 3 different identities for cosine 2a. And since they gave me sine a, I'm going to use the one that only involves sine squared a. So I don't even really need the triangle. I can just plug in. They tell me the sine of a is 3/5 squared. So this becomes 1 minus 2 times 9 over 25. So turn this into 25. 25 minus 18 is going to be 7. So this becomes 7/25. All right. And so now we want to evaluate sine 75, so we're going to rewrite that as 30 plus 45 and use our composite to expand. So that's sine 30 cosine 45 plus cosine 30 sine 45. So sine 30 is a half, cosine is rad 2 over 2. Cosine 30 is rad 3 over 2 plus rad 2 over 2. That all simplifies to rad 2 plus rad 6 all over a common denominator of 4. And then we go on to the next one. So we have a plus here. So 5 theta is A, 4 theta is B. This has the form of cosine A minus B, because there's always the opposite sign with the cosine. So 5 theta minus 4 theta is just theta, root 3 over 2. So we take the inverse cosine, root 3 over 2. That gives me plus or minus 30 degrees plus 360n, so they just want the particulars. So that will be 30 degrees. Negative 30 is equivalent to 330 degrees, and those are going to be the only values from 0 to 360. Then we have 2 sine x cosine, so we can convert that into sine 2x, because that's the identity, equals 1. So 2x will equal the inverse sine of 1. Now this is a quadrantal angle, so you're only going to have the one answer, pi over 2 plus 2 pi n, but that equals 2x. So we're going to divide everyone by 2, so that my final general solution is pi over 4 plus pi n. That's the general solution. And within 0 to 2 pi, you'll have pi over 4 and 5 pi over 4. That was supposed to be a plus. That would be your particular solution. So those would work there. And then lastly, we have the proof. So basically, I'm going to turn everything into one of their equivalent identities, but knowing that tangent is sine over cosine. So when I do the 1 minus cosine 2 theta, I'm going to use the identity that has sine in it, 1 minus 2 sine squared theta. And then down below, you only have one choice for sine 2 theta, which is 2 sine cosine. And so from that, we can start to, this 1 will distribute. So 1 minus 1 is 0, and we get a positive 2 sine squared theta all over 2 sine theta cosine theta. So the 2's will cancel, one of the sines will cancel, so that leaves me with sine over cosine which is in fact a tangent. All right, I hope that helped.